Hello, geometry friends. How lovely to quote unquote see you. It's Miss Wait here. It's time to start talking about triangles, y'all. And we're going to be talking about triangles for a while. So today is kind of jumping into a new chapter. If we were in the textbook at school, we'd be in chapter 5. So you might notice that in Big Ideas Math, we jump forward to 5. The assignments will be like 5.1, 5.4, stuff like that. Anyway, we're going to take what we know about angles and now turn it into triangles. And as we continue through this year, we're going to keep adding to what you know and adding a little bit further so that you can understand the basics and then kind of, I don't know, keep adding more. So now would be a good time to pause this video and consider this warm-up. And it's a little bit different. I just want you to think about where in the world you find triangles. When you look around in the world, where do you find them? Try to think of 3 specific places and then try to consider, why are the triangles there? Why are they where they are? You know, when you find a triangle in the world, why is it where it is? And then um, while you're thinking, get a piece of paper and a ruler or some sort of straight edge and a pair of scissors and carefully draw a fairly large triangle on your paper and then cut it out. We're going to use that for a little investigation during the course of this lesson. So go ahead and pause the video and do that. Okay. So, where in the world do you find triangles? Well, they're all over the place. Once you start to notice triangles in the world, you're going to find that they are everywhere. Every building, even though it looks like it's made of rectangles, if you take the covering off the walls, the drywall and stuff, inside of those walls, you're going to find triangles. All kinds of places have triangles. Bikes have a triangle in their support structure. There's triangles everywhere, so they're all over the place. We're going to talk just a little bit more of where you find triangles. Hopefully you've got this triangle cut out and waiting for the investigation, so let's keep going. Make sure that you also take a moment to update your notebook. Look back at a previous page, find yourself a place to write some questions, get a summary written in there, just recall the information that we've talked about before, and then get a new note page ready. And come on back when you're done with that. Okay, so here we go. Let's start talking about triangles. And the essential question is, how are the angle measures of a triangle related? The topic is the triangle sum theorem. So you're going to be getting another theorem today. So remember that postulates and theorems are kind of the keys to understanding geometry. So make sure you write them down. Let's get started. So the thing about triangles is that they are super useful, and that's one of the reasons why we study them. We are going to find triangles everywhere we look once we really start looking. I took these pictures, well, I didn't take the first one, but I took the second one of the Astoria-Megler Bridge, and hopefully you've been up the coast. This is Highway 101, and you get to Astoria, and if you want to continue over the Columbia River over to Washington, you'll cross this bridge, and it's a little hard to tell from the picture, but this is a very tall bridge. Huge container ships from all over the world go underneath this bridge at its highest point, and they've got to be able to clear this bridge when high tide, low tide, during winds. It's a really stormy place right here, and so this bridge has to be very, very strong. The other thing about this bridge is it is over, I think it's like 6.2 miles long, something like that, 5.2 miles long. Anyway, it's very long, and the Columbia River is an incredibly strong river. Great big tides come through this point all the time. So this bridge needs to stand for a long time, and it needs to be useful to the people of the area. And if it fell, it would interrupt shipping all up and down the West Coast. It would be a really bad thing. So they made the Astoria-Megler Bridge out of what you'll see in this smaller picture, a little more close-up, of triangles. It's essentially all made of triangles. And the reason why is because triangles are the strongest shape. You have to destroy a triangle to collapse it. If you make a box, you can push it over, actually, pretty simply. But a triangle, you have to apply an awful lot of force in order for it to collapse. Something actually has to break within that triangle. And so that's why we build things out of triangles, because it's a very strong and supportive shape. I always say, you know, if you don't have supportive friends, make friends with a triangle, because they're very supportive. All right. But triangles are in other places as well. Now, this is a bit of outdated information, but back in the day when people were starting with computer graphics, it was tricky to get a picture to load on a computer. It would take a really, really long time because it had to load each point individually. And then computer programmers decided that there was this other way of doing it called triangular mesh. And this cut down the number of points that needed to be loaded, and so it made loading faster, but it also, by the way you shaded a triangle in this triangular mesh design, you could make an object look more and more three-dimensional. And as soon as triangular mesh design started happening in computer graphics, that's when things got a whole lot more realistic, and you had this nice balance between the realistic look of an object and then also the ability to use that object or see that object on your computer because it loaded a lot faster. Triangles are also really helpful in measuring height and distance. We're going to be talking about a little bit of this further on in our class. Hopefully we'll get to the point where we're talking a little bit about trigonometry in this class. But this is a woodcut that was sort of depicting a scene. Notice that it says C263. This is a year that this sort of idea was very common knowledge. And the ability to measure the height of a sea island from not having to be on that sea island has been around and in human existence for a very, very long time. This picture comes from a book that was published in 1726. So we've been using triangles to measure height and distance for as long as you know, humans have been technologically advancing. So triangles are great, and that's exactly why we study them, because we use them all the time, and they come up in human existence just all the time. So the first thing we need to think about when we're talking about triangles is what to call them. And these words are going to be pretty familiar to you. When you're looking about there's two ways of classifying triangles. There's by sides and there's by angles. So if you want to classify triangles by sides, there's three types of triangles: the scalene, the isosceles, and the equilateral. Equilateral, equal sides. So scalene triangle is where there are no congruent sides. And since that triangle has no markings, there's no little hash marks saying that any sides are congruent to one another, any triangle that doesn't have hash marks, you have to assume is a scalene triangle. In other words, all the sides have a different measure. An isosceles is what happens when you have at least two congruent sides. If two sides of any triangle are congruent, it's called an isosceles triangle. And then the last one, suggested by its name, meaning equal, lateral meaning side, equilateral triangles have three congruent sides. And those are the three types of triangles that you get when you classify them by what you know about their sides. When you're talking about angles, there are four types. There's the acute, the right, the obtuse, and the equiangular. So the acute triangle has three acute angles. The right triangle has one right angle. The obtuse triangle has one obtuse angle. That's all it takes to be an obtuse triangle, one obtuse angle. And then very much like equilateral, we have the equiangular. Equi meaning equal, angular meaning angle. Equiangular triangle has three congruent angles. And these can be mixed and matched. You can have isosceles right triangles. You can have equilateral and equiangular actually are kind of the same thing. And we'll talk about that as we move forward, but these are the ways that you can classify triangles. So now grab that little triangle, that relatively large triangle that you set aside during the warm-up, and if you haven't done it yet, you could do it now. On a piece of paper, use a ruler to carefully draw a triangle, and then cut your triangle out. Then take the corners of your triangle and rip them off. kind of a little far back from the vertex. Just rip those corners right off. And then take the points of your triangle and bring them together, and then bring them so that they're quote unquote lined up. And you'll see what I mean. There should be touching each other at the vertex, but also touching each other on the sides, and line them up. When you do that, they form a specific geometric object that we've been doing some studying about. So if you haven't drawn the triangle, go ahead and do that. Go ahead and pause this video and do this little investigation and see what you come up with. Okay, so let's look at this. So I have this triangle here. This is the one I've drawn on my whiteboard or my smartboard. And what I've done is I've taken these corners and I've created them so that I could quote unquote rip them off. So there's that one, and there's that one, and there's that one. Oops, it's a little bit light, but you can still see it, I hope. Now what I'm going to do is I'm going to bring them together. So I'm going to bring this one over here. Oh my, it's not cooperating. And then I'm going to take this one and I'm going to turn it, whoop, so that I can put these right next to each other. Just like that. That's what you want to do with your corners, so that they're sharing not only a vertex but also a side. And now I'm going to take this third one. I'm going to flip it around so I can put it next to these other ones. Almost there. All right. Now it's not perfect, but what I'd like you to do is notice what happens when you put those triangles together. You've got this angle plus that one, and the object that they make together is this side right here. What kind of object is that? I hope you said line segment. And what would you get if you took this angle? Since this is a line segment, what would you get if you took this angle plus that angle plus that angle? Well, you'd have to get 180, wouldn't you? You'd have to. And it wouldn't matter what your triangle looks like. This is going to happen every single time. And when any triangle you draw, you could try the investigation again and notice that no matter what triangle you draw, if you rip those corners off and you put them together, you're always going to get a line, which suggests a theorem. The theorem that I'm specifically talking about is called the triangle sum theorem. And it goes like this. All three interior angles of any triangle sum to 180 degrees. That is the triangle sum theorem. All three interior angles of any triangle sum to 180 degrees. And you can see that this is expressed as an algebraic equation right here. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees every single time. Now that's something you might have already known, but maybe what you don't know is how to use it. And so that's what we're going to talk about next. So we can use this theorem, the fact that all three interior angles of any triangle sum to 180, to find missing angle measures. So we've got this triangle here. One angle measures 27 degrees. I'll call that angle A. Angle B measures 122 degrees, and we're being asked to find the measure of angle C. So what we know from the theorem is that the measure of angle A plus the measure of angle B plus the measure of angle C always equals 180 degrees. It really doesn't matter what triangle you have. So now we can put those measurements into those spots and use some algebra. So measure of angle A is 27 degrees plus the measure of angle B, which is 122, plus the measure of angle C. Actually, let's write it how it's labeled. X equals 180 degrees. And that's how you can use this theorem to get you an equation that you can use to solve for x. Now it's a matter of using algebra. The first step is to combine like terms. So you have 27 plus 122, and I'm going to shamelessly use a calculator so I don't make any mistakes. 27 plus 122 is 149. plus x equals 180 degrees. And I'm just going to leave the degrees off for now. And then what do I have to do to solve for x? Well, I have to subtract 149 from both sides. These cancel. I have x equals whatever 180 minus 149 is. It's 31. And so I know that x is 31 degrees. Knowing the triangle sum theorem will make it so that you can solve for missing angles. If you know all three of them have to add to 180 and you know two of them, you can use the theorem to solve for the third. Now, some of you might have noticed that there's quote unquote an easier way, which is to take 122 and add it to 27, which is 149, and then just subtract that from 180. You're still going to get 31. And that's fine. The reason why I do it this way, first of all, it helps us get practice using the theorem, which is the good practice that we want to get into. Also, things get more complicated, and I'm trying to help you build good habits. That using the theorem to create an equation and then plugging things in and using algebra will help you remember how to do those steps, so when things get a little bit more complicated, you'll have the steps to do it. You can just take 122 and 27 and add them up, and then subtract that from 180 and get 31, sure. But building good habits is, part of helping you build good habits is like part of my job. So that's what I'm doing. All right, let's keep going and do more stuff like this. All right, so let's call this one angle A here, angle B, and angle C again. Now, it looks like we only know angle B, and we're trying to find angle C. What do we know about angle A? Remember what that box means? It's 90 degrees, right? So we can still use the triangle sum theorem. You could use it on any triangle. And what it says is that if you take the measure of all three angles and you add them up, you get 180 degrees every single time. Now we just replace with the values that we know that those angles are. Angle A is definitely a 90-degree angle, and so we can put that there, plus the measure of angle B, which is 47, plus the main measure of angle C, which we're calling x, has got to equal 180. And now this problem is just like the last one we did. Add up the numbers and do some subtraction. So 90 plus 47 is 137. 137 plus x equals 180. Subtracting 137 from both sides creates this cancellation, and we have x equals 180 minus 137, which is 43. And now we know that this is 43. Now here's something to think about. Going this way, using the theorem will get you there every single time, but you might notice that in a right triangle, if 90 degrees is already used up, then these two angles have to also add to 90 degrees, right? Because 180 minus 90 is 90. So you could just take this idea and subtract that 47 degree from it and still get 43 degrees. It's fine. The thing about working math, one of the things that people dissuade you from doing is finding your way to solve it. I have a way that I prefer, that I can see a future in. It's building good habits so that you are, when things get complicated, you have a method to rely upon. But I also want to encourage you to be clever. If you see it a different way, that's okay. You can just take 47 and subtract it from 90 because angles B and C have to add to 90 because angle A has already taken 90 degrees away from that original 180. So it's okay, regardless how you do it. Just do it. Now, the reason why I wanted you to build good habits is because we don't always use numbers to solve problems. We want to be able to use the concept to solve any problem. And so if we remember, and let's label these again, we have A, B, and C. If we remember the theorem that tells us that the measures of the three interior angles of any triangle add to 180, we will not be worried about what happens when problems look like this, because we can just jam those values into those spaces and use algebra to solve it. So what do we know about A? Well, we know A is 90 degrees because there's a little box. What do we know about the measure of angle B? Well, it is 2x. And then the measure of angle C is x minus 6. And it's okay to drop those parentheses because that's just a unit at this point telling you that x minus 6 represents a degree measure, and that's going to equal 180. And that's how understanding what the theorem is telling you can help you build an equation that you can then solve to find the answer. So now we have this equation. Now clearly we're going to have to combine like terms. So we're going to combine 90 minus 6 and get 84. I guess I probably could have done that in my head. And then we have 2x's plus another x for plus 3x. And then that's going to equal 180. All right, we're still trying to get at x, and so let's get rid of 84 on each side, creating this cancellation. We have 3x equals 180. Do I get louder when I'm looking at my calculator? I probably do, because I'm closer to my microphone. All right, 3x equals 96. And then dividing both sides by 3 gives us x equals 30. Well, hello. You know, the battery on my mic died, and I might have just been gone for a couple seconds for you guys, but I have been all over the school looking for batteries, and then I had to drive to Roth's and get batteries, and now I'm back, so I'm a little bit out of breath. But let's continue this video, shall we? Anywho, I kind of forgot what I was saying, but the bottom line is that x is 32, and that's fantastic. Yay. And so now we can actually answer this question, find the measures of the angles, because we're not asked what x is, we're asked what the measures of the angles are. But that's okay, because we can just take this 32 and we can plug it in. We know that the measure of angle B is 2 times whatever x is, or 2 times 32. And so we know the measure of angle B is 64 degrees. Now, we could do angle C any number of ways. We could just subtract that all from 180, or we could just do measure of angle C is 32 minus 6. 32 minus 6. What's 32 minus 6? What's that, 24? Oh man, see, running out to the store, I've completely disposed of my brain. 26, Miss Wait. All right, it's okay. 26 degrees. So now we have the answers that we were looking for. And it all starts with understanding the theorem. The triangle sum theorem that tells us if you take all three interior angles of a triangle and you add them together, you're going to get 180. And then no matter what those interior angles are, numbers, algebraic expressions, whatever, you can always solve the problem. Okay, so that's it. I hope you have a wonderful day. Your practice is in Big Ideas Math. It's called the triangle sum theorem. How are the angle measures of a triangle related? Well, they add to 180 degrees, don't they? All right, you guys, have a wonderful day. Talk to you later. Bye.